When I co-founded Lectrolyst in 2018, we had an idea of where all of this was going to go, but we were working on a very tiny scale. So this was our 1 square centimeter, very small unit that was used for demonstration purposes. And then we started getting into something that was a little bit more familiar to people in our area, and then larger and larger into 100 square centimeters, 400 square centimeters, and then finally up to something where we're now at over 10,000 square centimeters in a large stack, which is a 10 kilowatt demonstration of our core technology. So a way a system like this works is you have a whole bunch of different plates all stacked together and all contributing to the same chemical reaction that you want to do. In this case, it's that transformation into the acetate product that we want to be capturing. So what you do is you power this on. So on the back there are electrical connections. When it's powered on, transformation happens. When it's not powered on, transformation doesn't happen. In this case, what we're doing is we're feeding in different gases, and it's being passed through this entire system, and then we're able to capture any of the remaining reactant as well as any of the products that are coming out of the electrolyzer. And then we also have liquid that's being recirculated through, where we're able to capture and concentrate up our acetate product that we're using for food production.
So one of the main products of our electrolysis process is acetate. We produce it in large quantities in this tank, and here in my hand I have a sample of our acetate product. We provide this product to large biotech companies that use a fermentation process to upgrade it further into things like edible protein. Fermentation has been used for millennia by human beings to produce bread, cheese, wine, a variety of products. So this really is nothing new in our food system. All we're doing is supplying a new feedstock to these companies. Traditionally, fermentation processes all rely on glucose, and the issue with glucose is it competes with our current food system. To produce glucose in the US, we derive that from corn. In Europe, they typically derive that from sugar beets. So by switching over that carbon feedstock to acetate derived from CO2, we can now decouple our protein production process from the existing food systems. And this helps produce a more sustainable process.
So this is our electrode fabrication station. We used to hand make our electrode for the 1 square centimeter demo style. And now we have scaled up and use this machine to make our electrode in large area and large amount. A lot of clean tech company, they use precious metal as catalyst. At Lectrolyst, we use non-precious metal such as copper, nickel, or other really abundant metals. In this electrode, that's where the carbon monoxide or carbon dioxide meet with the liquid electrolyte, and the electrochemical reaction happens and converts those waste carbon materials into valuable feedstocks like acetate, ethylene, and other valuable products.